Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Guys, welcome to Vaishnav 360. Today we are going to do functions exercise 1C introduction. First of all, we should see that there are few formulas which we have to know to do exercise 1C. Okay, those formulas are, first one we will take the sets F maps A to R and G maps B to R. Okay, now here AR and BR, this is in between F, this is in between G. Okay, like this, right? Here also like this. Now one more thing, this is union and this symbol is intersection. Okay, now we will start. Now we will start the formulas, that is f plus or minus g of x is equals to f of g plus or minus g of g of x. Okay, now this is the first formula. Now the second formula, that is f of g of x is equals to f of x into g of x. Now the third formula, f plus c of x is equals to f of x plus c, and the fourth formula, c of f of x is equals to c of f of x. Okay, now the fifth formula, that is f by g of x is equals to f of x by g of x. Now the next formula, that is modulus, modulus of x, modulus f of x is equals to f of x whole modulus. Now the next one, f to the power of n of x is equals to f to the f of x whole to the power of n. Now the last formula, but not the least, that is f root into x is equals to under root f of x. Okay, now we will check out unions and intersection. Before checking unions and intersection, let's read all the formulas once again. Okay, now f maps A to R and G maps B to R. F plus or minus g of x is equals to f of x plus or minus g of x. F into g, that is fg of x is equals to f of x into g of x. F plus c of x is equals to f of x plus c. Cf of x is equals to c into f of x. F by g of x is equals to f of x by g of x. Modulus f of x is equals to f of x whole modulus. Now f to the power n of x is equals to f of x whole to the power n. Under root f of x is equals to under root f of x. Okay, now we will go to the domains part. Okay, now we are going to the domains part, that is Wait a minute, let me adjust. Yeah, okay. Now the domains part, that is domain f plus or minus g is equals to domain of f intersects or intersection of domain of g. Domain of f by g is equals to domain of f intersection of domain of g and domain of under root f is equals to a domain of f inverse of x maps f of x greater than equals to 0. Okay, wait a minute, here something is wrong. Yeah, here it is f of x, not f divided by x. Here I will write fg. Okay, this is fg. This is domain fg is equals to domain of f intersection of domain of g. Okay, now I will write domain of f by g is equals to domain of f intersection domain of g, again an intersection. Now x maps g to x is not equals to 0. So here if there is intersection between domain of f and domain of g, then we should think that there is an what do you say, there will be common elements in this and this. So domain f plus or minus g takes the common elements in these both, that is domain of x, domain of f and domain of g. Okay, now let me take an example first. Actually I should tell the example before the domains part, but it will be simple and easy if I tell first the domains formula and then the what do you say, example. Okay, now I will take an example. A and b, I think all will be know in the starting of the introduction. I have told this part, that is this is domain and this is codomain. 1 2 3 4 5 6 7, this is domain and this is codomain, d dot co dot d. Okay, this is f maps a to b. Now what is domain, that is d dot is equals to 1 comma 2 comma 3. What is codomain, 4 comma 5 comma 6 comma 7, right? What is the range then? 1 2 and 3, there is not here 1, so this element will be left at here. So the range here is 4 5 6, 4 5 6. So here we have common elements in codomain and range, that is 4 5 6 here and 4 5 6 here. Now I think you would understand, if there is any common elements here, it would be taken as a range. Okay, now we'll go forward to the second one. Okay, now we will see the second one, what is even function and odd function. Now first it is even function. Even function is nothing but if f of minus x for every x in A, then f, than f, sorry, not then, than f is called an even function. I hope all can see what I am writing here. The clarity is good. Yeah, okay. Now, even function is nothing but if f of minus x for every x in A, then f is called an even function. Okay, let us read it again. If f of minus x for every x in A, then f is called an even function. Now we'll see what is odd function. What is odd? What is okay? Now here, what is odd function? Okay, odd function is nothing but if f of minus x is equals to minus f of x for every x in A, then f is called an odd function. Let us repeat it again. Okay, odd function is nothing but f f of if f of minus x is equals to minus f of x, then for every x in A, not then, here there is no then, for every x in A, then f is called an odd function. Let us repeat it again. There should be no confusion in even or odd function. That's why I'm repeating it again and again. Okay, if f of minus x is equals to minus f of x for every x in A, then f is called an odd number. Okay, now we are going to learn the next one. Here we have the next one, that is we have more two formulas, a type of formulas. Okay, we'll check it out. Okay, if there is x minus alpha, that is alpha means any variable, into x minus beta or of x minus beta, that is another variable, is greater than equals to 0, then x is smaller than or lesser than equals to alpha, or x is greater than equals to beta. Okay, now this is a type of formula where here x should be present in both the sets, and there should be uh, any other what do you say, variable or a number, or it should be real number. Okay, any real number with sign minus in the both the sides, then there x is smaller than equals to alpha, or x is greater than is equals to beta. Here we should see if there is or and in any question in functions, then we should fix in our mind that if there is or, it is union. It is union. If there is and, it is what is this? Comment me in the comment section. Yeah, this is nothing but intersection. Okay. Now we have another formula, that is x minus alpha or x minus beta is lesser than or smaller than is equals to 0, then alpha is smaller than equals to x, and here x, or we can say and or okay, or x is equals to smaller than beta, and we can write it as alpha is smaller than x and x is smaller than beta, smaller than equals to, okay, sorry. Now I am going to explain you an simple example so that you can understand the total concept here. A simple problem only, okay? I am with a small example problem here. Now we are going to do the example, that is find the domain of the following real value functions, real valued functions, okay? Now the first one is f of x is equals to 1 by 6x minus x square minus 5. First we'll do the first bit, okay? That is, here we should take f of x is equals to 1 by 6x minus x square minus 5. We can divide it by 1 by 6x means 5x minus 1x, and again we can do minus x square minus 5, okay? We can divide this like this, and then we can take it as, we should take common, no? First we will divide this and this into 2, okay? This is one part and this is one part. Now we'll take common, that is, I think we have to take this and this as one and this and this as one. Now we will take uh, first x square minus 1x, okay, and here uh, 5x minus 5, okay. Yeah, let us take like this, and we will take common here. This is a plus, no, so here plus only. Now we will take here x square minus 1x, that is x minus 1 of x, and here 5 of x minus 1, okay. Here we can take it as x plus 5 of x minus 5, okay, x minus 5. We can take it as like this, and then we can write x plus 5 of x minus 5 is not equals to 0, and then we should write x plus 5 not equals to 0, sorry, here x minus 1, no, and here x minus 1 not equals to 0, then x is not equals to minus 5 and x is not equals to 1. So we'll get the total answer, that is x is not equals to 1 comma minus 5, and therefore domain domain of of f is r slash or r maps 1 comma minus 5. This is the answer for the first bit. Now we will go to the second bit, that is uh, f of x is equals to 1 by under root x square minus a square, and there is a note that is a is greater than 0. Okay, now we are going to do the second bit. Now we are going to do the second bit. Okay, that is what it is. The second bit, f of x is equals to 1 by under root x square minus a square. Okay, now and here it is a note that is a is not a is greater than 0. Okay, now we will take x square minus a square that is greater than 0. Okay, we'll take this part. We should not take root here. X square minus a square is greater than 0. Now this is a square minus b square format. No, now we can write it as x plus a of x minus a is greater than 0. Now x plus a is greater than 0 and x minus a is greater than 0. Now x is I think, wait a second, wait, I will take it up. Okay, now x is here um, smaller than minus a, and x is greater than plus a. Okay, here we have took this, and now we will take, that is x belongs to minus infinity comma minus a, that is from here till left side end, and which is union with a comma infinity, that is from plus a till the end, that is infinity. Okay, this is the answer, and the original answer is domain of f is minus infinity comma minus a and union with a comma infinity, that is equals to r slash minus a comma a. Okay, this is the answer. Now we are going to do the third bit, that is nothing but x of f of x is equals to x plus 2 of x minus 2 x minus 3 under root. Now we are going to do that. Now we are with the third bit, that is f of x is equals to x plus 2 and uh, x plus 2 of x minus 3. Okay, now we are going to solve that. Wait a second. Now here we should take x plus 2 and x minus 3 is not equals to 0. Okay, now here it is better to take greater than like this. Okay, I will write here again x plus 2 of x minus 3 greater than is equals to 0. Okay, because it is real numbers, here I will write it belongs to real numbers. Sorry, here. Okay, I will it is better option to take this because it belongs to a real number. Okay, now here we can take x plus 2 of x minus 3 greater than or equals to 0. Then we will take separately, that is x plus 2 greater than 0, x minus 3 greater than 0. Now x here we will take this sign changes now like this. Okay, minus 2 and here x greater than is equals to 3. Okay, this is what is x. Now we will write x belongs to minus infinity to minus 2, minus infinity to minus 2 here, and here x belongs to 3 to infinity. Okay, this is the answer, that is r slash or r maps minus 2 to 3. Okay, this is the answer. Now we should write whole statement in one as an last answer. So therefore domain of f is x belongs to, or r, here r slash minus 2 comma 3. This is the answer for domain of f. Now we will do fourth bit, that is f of x is equals to x minus alpha and beta minus x. Now here 0 is less than alpha and alpha is less than beta. Okay, this is the note given here. Now here we have the fourth bit. Now we can take x minus alpha and beta minus x is greater than equals to 0. Now x minus alpha is greater than 0 and beta minus x is greater than 0. We can take x, uh, yeah, x greater than alpha and beta greater than x. Okay, now here we will get alpha is smaller than equals to x and x is smaller than equals to beta. Okay, since alpha is smaller than or less than beta. Okay, now this is the answer for the fourth bit. We should write therefore statement now. Here x belongs to alpha comma beta, and here therefore domain of f is x belongs to alpha comma beta. Okay, now that is r slash alpha comma beta. This is the answer. We can write this or this, any answer. Okay, in therefore statement we can write domain of f is x belongs to alpha comma beta, and r, that is range slash alpha comma beta. Okay, now we are going to do the fifth bit, that is here, where it is fifth bit. Oh my god, I forgot to write fifth bit only. I'll write and tell you what it is. And sixth one is here. I have written sixth one here because there is a lot of insufficient space here. So here I thought it would be sufficient for seeing for you all. Okay, here this is the sixth one. Now I am going to do fifth one, that is f of x is equals to under root 2 minus x plus under root 1 plus x. Okay, now here we are with the fifth question, and this belongs to real numbers. Okay, Now we are going to do the problem now. Here we are going to take 2 minus x is greater than or equals to 0, and 1 plus x is greater than or equals to 0. Okay, now here 2 is uh, greater than is equals to x, and x is greater than is equals to minus 1. Now here we can take minus 1 is smaller than is equals to x, and x is smaller than is equals to 2, that is plus 2. Okay, now we can take that is x belongs to minus 1 comma 2, and then this is the answer. The original answer is domain of f is x belongs to minus 1 comma 2. Okay, this is the answer of the fifth bit. Now we are going to do the sixth bit. That is the sixth bit is f of x is equals to under root x square minus 1 plus 1 by under root x square minus 3x plus 2. Okay, we are going to do the sixth bit now. Now here we are with the sixth bit. Now we are going to do the sixth one. That is f of x is equals to under root x square minus 1 plus 1 by under root x square minus 3x plus 2, that belongs to real numbers. Sorry, this belongs to real numbers. Okay, now let's solve. Okay, this I think this would be an problem which can be asked in the exam, like this type of problems, not this problem only. Okay, now we will solve this. That is, wait a second. Now uh, we will take here x plus 1 of x minus 1, uh, that is greater than is equals to 0, and again x minus 1 x and x minus 2, that is greater than 0. Okay, first we will write here x square minus 1 greater than is equals to 0, and x square minus 3x plus 2 greater than 0. Now here x x plus, this is we can take here square now. Now here x plus 1 of x minus 1, here we can take square because 1 into 1 is 1 only, no, that's why is greater than is equals to 0, and here x square minus 3x plus 2. So here we can take minus 2 and minus 1, x square minus 2x minus 1x, okay, plus 2. Here we can take this, and here we will take x of x minus 2, and here minus 1 of x minus 2. Yeah, then here we'll get x minus 1 of x minus 2. Here I will write greater than, only greater than 0, not is equals to, only greater than 0, and here only greater than 0. Okay, now here we will get x plus 1 greater than or equals to 0, and x minus 1 greater than and equals to 0. This here 2 bits, and here also will get x minus 1 is greater than 0, and x minus 2 is greater than 0. Now we will get two types, this one and this one. Now we are going to do the substitution, that is Now we can take it as x plus, no, here we can take x is smaller than is equals to minus 1 and x is greater than is equals to 1. Now we will get x, uh, I did some mistake here, wait a second. Here I think I will get like this is wrong. Here I will get x greater than is equals to minus 1 and x smaller than is equals to 1. Okay, now the total answer will be x, okay, wait, I did here wrong. Minus 1 smaller than is equals to x smaller than is equals to 1, and here totally you can write x belongs to, that is, here x belongs to what, minus infinity till minus 1, that is union with 1 comma infinity. Okay, and another one will get here x, that is um, x is here smaller, no, x smaller, x is greater than 1 and x is here this side smaller than 2. Okay, now we will get here x is, that is x is this is greater, no, here 1 is smaller than x and x is smaller than 2. This would be the answer for this, and here in the continuation we can write x belongs to what it is. Here x belongs to nothing but minus infinity to 1, which is union with 2 to infinity, 2 to infinity, like this, infinity. Okay, this is infinity. Okay, this would be the answer. Here we can write r, that is range slash uh, minus 1 to 1, which is union with minus, sorry, which is union with 1 and 2, 1 to 2. Okay, now here we can write x belongs to r slash minus 1 comma 2 is equals to minus infinity to minus 1 with, this is curved bracket and this is a block bracket, and which is union with 2 comma infinity, that is r range slash minus 1 comma 2. This is the answer for the sixth bit. Okay, this is the total solution for the sixth bit. Now we are going to do the seventh bit. Okay, now we are going to do the seventh bit, that is f of x is equals to 1 by under root modulus x minus x. Okay, now we are going to do the seventh bit. Now here we are with the seventh question, now which is belongs to real numbers. Now we will do that question. Now here we can take modulus x, here, yeah, modulus x minus x greater than 0, that is modulus x is greater than 0 sorry, greater than x here, sorry, this is a mistake, and we'll take x belongs to minus infinity to 0. Because we don't know what is the value of x, we'll take it as 0, and it should be appropriate uh, because there is a modulus in here. It should be an appropriate, that is plus or minus. 0 is not neither a negative or positive number, so we will take 0 directly, minus infinity till 0. Okay, therefore domain of f is minus infinity comma 0. This is the answer for the 7th bit. Now we are going to do the 8th bit, that is, now here we have the 8th bit, that is f of x is equals to under root modulus x minus x. This is the 6th bit, we have done it already, we will keep it aside. Okay, this is only the problem which we are going to do now. We will start with it. Now here we are with the f of x is equals to a modulus, this is not brackets, modulus x minus x. I'll write it here, this is too congested here, minus x here under root. Okay, f of x. Now it would be clearly visible for you. Now this is the problem which belongs to real numbers. Now we will take uh, modulus. It is same as 7th question, but there it is divided by 1 in 7th question, this term, this whole term, but here it is not taken. As it is same, so we can write it as modulus x minus 1 is greater than 0, that is modulus x is greater than x and x belongs to minus infinity comma 0, as I have explained in the 7th question, and therefore domain of f is R, as it is it is true for all x belongs to R. Okay, this is the statement here, since, okay, since statement this is. Now this is the answer for the 8th question. Thank you for watching. Now we have completed all the what do you say, all the introduction to exercise 1C. Now thank you for watching.